Hello everyone, I'm Xiaozhu. The paper I'm going to present is FootUI, assisting people with upper body motor impairments to use smartphones with foot gestures on the bed. We focused on people with upper body motor impairments but some lower limbs. Our target group contains people with upper body paralysis, both arm amputees, and those who just got their upper body hurt and can only use feet for upper limb compensatory. To understand how they usually use smartphones in their daily life, we conducted formative interviews with 3 participants. One of them has severe upper body paralysis with dysphonia, and the other 2 participants are both arm amputees. According to the interview, we found that they all interact with smartphones by touching the phone screen with big toes and are usually use smartphones on the bed. They are unsatisfied with current input method because of the mistouch and the difficulty to perform complex gestures. They also express a need for additional auxiliary clamping tools and a preference for indirect click like mouse. We also found that they prefer ankle-based gestures to toe-based gestures and are able to lift their feet for a long time. Furthermore, we also investigated the necessity of several smartphone shortcuts for them. According to the investigation, we proposed FootUI to help them use smartphones on the bed with foot gestures. As the figure shows, we define the usage scenario as the user reclines on the bed with a smartphone fixed on the smartphone holder and feet within the view of the phone camera. The camera is always on to track the user's feet and map the foot gestures to smartphone operations. Based on the usage scenario and prior research, we propose a foot gesture set which contains 3 dynamic continuous gestures and 8 discrete gestures. Dynamic continuous gestures means gestures that can be tracked continuously with real-time dynamic feedback, and discrete gestures means those can be used as iconic triggers for commands. As for the tracking and recognition technique, we segmented the foot from the background by color in HSV space, detected the contours of the feet, and extracted feature points. The right foot fingertip is tracked smoothly and mapped to cursor movement. The stroke features were extracted according to the direction and angle and were used for discrete gesture recognition. The table shows the performance of gesture recognition algorithm. The smartphone operations were divided into basic operations and shortcuts. The figure shows the mapping from foot gestures to smartphone operations. We mapped the foot gestures to smartphone operations following the rule of mapping the most user-preferred foot gestures to most necessary smartphone operations. Finally, we designed the user interface of FootUI. The yellow dot on the interface is cursor, which is a mapping of the right foot fingertip. There is a floating camera view at the lower right of the interface, which can display the user's current foot motion. We also set scroll buttons in the lower right corner of the interface based on the fifth law. Users can tap the button with cursor instead of scrolling with the foot. The lower left corner of the interface is the short menu button, which pops up the shortcut menu. We recruited 14 able-bodied participants and 2 both-arm amputees to evaluate FootUI through an interactive task, which can be divided into 10 subtasks. The quantitative feedback shows that robustness for gesture classification algorithm remains to be improved, but the overall performance of FootUI is acceptable. Participants also provide their subjective feedback about FootUI from the perspective of user satisfaction, fatigue, ease of use, and learnability. Their qualitative feedback shows that FootUI is easy, efficient, and interesting to use, and is especially convenient for phone browsing when the upper body motor impaired user reclines on the bed. In conclusion, we present FootUI, a novel interaction technique that assists people with upper body motor impairments but some lower limbs. This work still has some limitations and remains for future work. First, because of the difficulty for recruiting upper body motor impaired participants, we recruited some able-bodied participants to our user study, and the number of our target group was small. We will recruit more upper body motor impaired participants to evaluate FootUI in the future. Second, the evaluation for the UI is rough. We will choose an appropriate baseline and evaluate for the UI thoroughly. That's all. Thank you.